significant figures. In physics, we are engaged most of the time with measurements of things. One major problem that we encounter is to question, is it accurate or is it precise? So here, we introduce significant figures to eliminate or minimize the ambiguity of the values obtained during measurement or solving. Now there are several rules in identifying significant figures. First rule, non-zero digits are always significant. For example, 528. It has 3 significant figures, and 8714 has 4 significant figures. Number 2, or the second rule, any zeros between 2 significant digits are significant. For example, 4014. It has 4 significant figures, and 2001. It has 4 significant figures. Third rule, zeros after a non-zero digit in the decimal portion are significant. For example, 0.00500 has 3 significant figures, and 0.0340 has 4 significant figures, and 0.0506 has 3 significant figures. Number 4. Trailing zeros in a whole number are not significant. For example, 2000. It has only 1 significant figure, and 25,000. It has 2 significant figures. Fifth rule. Zeros between a decimal point and a digit are not significant. For example, 0.005 has 1 significant figure, and 0.00005 has 1 significant figure. Number 6. Zeros between a digit and decimal point are significant. For example, 50. It has 2 significant figures, and 500. It has 3 significant figures. Seventh rule. Zeros after this decimal point are significant. For example, 33.0 has 3 significant figures, and 11.00 has 4 significant figures. We can write it in scientific notation to change its number of significant figures, like you just need to write in a manner that it can have certain number of significant figures. Now how about performing basic operation involving significant figures? There are also rules if you perform basic operations like addition, subtraction, multiplication, and division. For addition and subtraction, you just add or subtract them in the normal way and round off your answer to the least number of decimal places of any number in the problem. For example, 12.4 plus 5.05. 12.4 has 1 decimal place and 5.05 has 2 decimal places. Our answer should be reported to the least number of decimal places, which is 1. Now we have 12.4 plus 5.05 is equal to 17.45. Then round off to the nearest tenths, we have 17.5. Now the answer is 17.5. Another example, 30.567 minus 20.15. 30.567 has 3 decimal places, while 20.15 has 2 decimal places. Our answer should be reported to the least number of decimal places, which in this case is 2. So we have 30.567 minus 20.15 is equal to 10.417. Then round off to the nearest hundreds, we have 10.42. The answer is 10.42. For multiplication and division, the least number of significant figures in any number of the problem determines the number of significant figures in your answer. For example, 2.5 times 3.42. 2.5 has 2 significant figures and 3.42 has 3 significant figures. So, our answer should also be reported with 2 significant figures, which is 8.55. Then round off to the nearest tens for us to have a 2 significant figure number. So we have 8.6. The answer is 8.6. Another example, 4.520 divided by 3.10. 4.520 has 4 significant figures, while 3.10 has 3 significant figures. So our answer should also be reported with 3 significant figures. So we have 4.520 divided by 3.10 is equal to 1.4580645. Then round off to the nearest hundreds for us to have a 3 significant figure number. So we will be having 1.46. The answer is 1.46.